Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopatz, and your host for Open Source Directions today, and co-hosting with me today is Madikin.
Hi, I am Madikin Muck, and I am excited to be joining as a co-host this episode. I am a postdoc at the University of Illinois, and I work on a project called the YT Project for data visualization, and I'm in Urbana, Illinois.
Thanks, Madikin. And joining us today as guests are Tom and Hannah. Tom, you want to go ahead and introduce yourself?
Hi, I'm Thomas Caswell. I'm a physicist by training. But I'm currently at Brookhaven National Lab working at the synchrotron, doing controls work and data acquisition, management, and analysis for our staff and users. And in my spare time, I'm the lead developer of Matplotlib.
Very cool. Hannah?
I'm a graduate student in computer science at the Graduate Center CUNY. I study visualization, especially high-dimensional heterogeneous data sets and climate data. And I'm working on my dissertation. I'm trying to make Matplotlib version for my dissertation, or at least parts of it.
Both are very bold individuals. And before we get into any of that, we will have a brief personalization section. So today, obviously, we have our visualization of the week or recent visualization. So everyone's going to sort of bring a piece of the viz, some recent visualization that they've been enjoying, and we'll just go around the horn here. So first up, Hannah, what's your viz that you want to show us? Or you can describe it, and Brandon will throw it in the chat there.
Okay, so there are two. One is the New York City subway map. And what it is, it's like a completely interactive story base where they kind of based it on Instagram stories where they start with highlighting with one part of the map and they tell you the history of it, and then they follow the map down and tell you the next piece, and then follow the map down and tell you the next piece. And so you kind of unfold the history of the map as the animation steps through.
Yeah, it's really quite neat. So
yeah,
here's that example there. Yeah. So go ahead.
Yeah, and then there's another visualization that I just thought was adorable, which was that, and this one's made in Matplotlib, and it's a little just spinny globe, and I kind of now want it to be the like spinny wheel on a couple of geoscience platforms, because what would be more perfect, really?
So perfect. Yep.
Yeah. Beautiful. Totally beautiful.
Oh no, I stopped presenting. So I'll get back to that. Well, thank you so much for the spinny globe in New York. Tom, what's your viz this week?
So I slightly panicked and decided to go with an educational visualization. And this is a figure from our docs, which explains the words Matplotlib uses to mean the various parts of a visualization, which are may not always match users' naive expectation. Because there are many words you can use to describe some parts of these, and these are what we mean by those words in the context of Matplotlib. I think, at least when I was first getting started using Matplotlib before I started contributing to it, the first time I sorted out basically what this figure was and what words things were, the whole library became much easier to use and started to make more sense.
Yeah, I refer to this figure still as I go through and I'm trying to debug some, plot I'm trying to make. It's super useful.
Excellent.
And it's by Nicolas Rougier, who's been making a ton of cheat sheets for us and has a book out soon on Matplotlib.
Exciting. That's great. Madikin?
Yeah, okay. So mine is actually a little bit older, but I recently rediscovered it. So it's something called Electricity Map. It was originally kind of open source, but I think now there's like a company managing it. And it's a live map of either production or consumption of electricity by regions of the world. And you can hover over different areas and see what their carbon impact is of whatever they're producing or consuming. There's also little arrows, like if you go to Europe, you can see if there is energy being transferred over the grid and what the carbon intensity of that energy is. And if you click on a country, you can also see the profile. So you can see kind of what things are contributing to what its overall carbon impact is. And so I found it really cool, and I really nerded out about it. So it's really fun. Right.
It also would make a great risk board, but that's probably besides the point. Yeah, this is great. So for my part, I will do something a little more comical, I think. My terrible map, or my map is from the Terrible Map Twitter account / Instagram. And this one is in particular the longest possible train journey in the world, which is simply this. I don't know why I thought this was like so funny, but I also think it's also kind of fascinating where it goes through and how it kind of like basically misses Mongolia, but there's like just that little tip right there. I don't know. It would be fun to do this, I suppose, you know, and it also kind of demonstrates to me that there are probably much longer train journeys possible. Like if you went over, you know, the Suez and down Africa somewhere, but it's just hasn't been done yet. So yeah, just to note. So I think
that account is also great. It's a really fun thing to browse.
Yeah, is that a single ticket?
I mean, I hope so.
A lot of that is the Trans-Siberian Railroad.
Right. Yep.
Right.
Well, most of it, right? Like this whole big chunk. But yeah. No, I just think it's really great. And this account is a lot of fun if you've never seen it. Please go check it out. All right. So with that, we will move on to our project introduction. So today we're talking about Matplotlib, yay, which is great. So Matplotlib sort of needs no introduction, but it's kind of the base layer of a lot of plotting and analytics in Python. And it's been around forever and ever and ever. It's got about 10,500 stars on GitHub, and there's just tons and tons of downloads. It's been bundled and shipped basically everywhere at this point, and gets around 800,000 to 900,000 monthly visitors to the documentation. So that gives you some inclination of how big and impactful the Matplotlib project is. So we're just going to go back and forth and ask a couple of questions here to Hannah and Tom.
Yeah, I'm super excited to hear a lot about your project. Can you tell us why this project was started and what need it was filling when it was started?
So the project was founded in the early 2000s by John Hunter when he was at the University of Chicago Medical School working in an EKG lab. They had more people in their lab than they had MATLAB dongles. And so John was trying to make a tool for solving his science problem and avoiding resource contention with his lab mates. At some point, the very, very early versions were wrappers around GNU plot.
Mm-hmm.
Over time, the project grew. He was in contact with Fernando very, very early on, right after IPython came out. Fernando said, I have to do my thesis instead of working on open source. So that is when John started building Matplotlib as its own thing instead of as part of IPython. So that is my understanding of the history. I was not there. And then over time, we have grown significantly. I don't have the exact year handy, but at some point, Perry Greenfeld at Space Telescope put a big push into getting Python accepted as part and used in the Hubble toolchain.
Mm-hmm.
and as part of that, they hired Mike Dropboom to work at Space Telescope and put a significant amount of effort into building out Matplotlib to what it is today. And then, yeah, it's a project that's been growing for 15 years, kind of organically.
It's almost 20. It says it started in 2001 here, so.
Well, I meant to go back and check. That's from memory. I meant to go back and check what our first Git commit was.
Yeah, but it lived on SourceForge for like a year or two before then.
Yeah, this predates Git by a fair margin, right?
Yeah, we were in SVN. We only have back to like SVN commit 5.
Oh,
and the first commit is a functioning library. So there is some history which is lost.
Yeah, right. Probably when the backgrounds are all black, right? Because it was new plot. But well, it's really great to see this come full circle, and now it can be someone's thesis rather than someone having to do their thesis independently of it. So are there alternative projects to Matplotlib out there, and what does that ecosystem look like a bit?
So there are many plotting libraries. Some of them are built on top of Matplotlib, such as Seaborn. We'll comment on that later. I think the important thing is to pick the tool that does the right thing for what you need. So if you need interactive visualization on a web browser running without a server, Matplotlib is not the right tool for you. But if you need embedding in a GUI or publication quality PDFs, that's where you should come to us. And the PyViz page has a full listing of them and this amazing basically mind map that Jake Vanderplas put together a couple of years ago, mapping out all the various parts of the Python plotting ecosystem and how they relate to each other.
Yeah, that's a super cool map. I like to look at it sometimes also. So I'm curious, actually, based on what you were mentioning before about kind of the beginnings of Matplotlib and how it was first built on GNU-Pot, what technology is it built on now?
So Matplotlib itself is a mix of Python and C++. Mm-hmm. A majority of the plotting logic and the business logic is in Python, and we use C++ when we have performance issues, for things that need to go fast, and for generating the rasterization. So like when you give you the raster image for a ping, we use a library called AG, which we've vendored, and that's a templated C++ library. And then if you want to do embedding in a GUI, we support all the major toolkits, TK, WX, GTK, Qt, and the native OSX framework. And we also use a bit of JavaScript because we do have a web and notebook front end or back end, which will allow you to have interactive figures either as a standalone web page running from a Flask server or in a Jupyter notebook.
Yeah, that stuff is really cool.
Yeah, so, I mean, this sounds very diverse in terms of the technology it's built on. Can you tell us a little bit about who maintains the project? Do you have really diverse maintainers as well?
Yeah, kind of. So we have our maintainers are generally, we've got a lot of it's grad students, postdocs, working scientists, academic scientists, programmers who work in industry and consultants. It tilts to, we kind of have and also we have the maintainers who like start out as grad students and now postdocs and are still working on the project, or start out as postdocs and now working scientists. Because we've had a bunch of people who've been around for like 5-10 years at least. And we have a lot of people who are coming out of climate science, oceanographers, meteorologists. We also have a lot of computational scientists, like computational physicists, computational biologists, computational neuroscientists, a lot of people on the experimental side. The reason we tilt, I think, towards scientists is just that's the people who they come in, they need a really specific thing, and they're comfortable writing code that they're not going to get hung up about to contribute back to the library to fix their thing.
Well, and they have this need for, I think, a lot of the bells and whistles, not to interject here, right? Like they need very specific real color kind of palettes, and they need it's nice to have LaTeX formatting and everything embedded, right? And
they're going to go deep into the library weeds to get just the thing they need.
Right. That's right. Tom, any further thoughts?
Yes. So in terms of size, I'd say our core team is about a dozen people, and those are people we hear from either on our weekly call, on the mailing list, or in issues of weekly to monthly. There's another 10 or 20 people who we hear from once a year, but they may be responsible for some big chunk of the library. And then we have probably order 100 or so people who will come by. They refer to as like drive-by commits. They'll come by. There's some bug they found, either the docs were wrong or they found an edge case in one of our functions that we weren't handling properly. They put in a fix, we merge it, and we don't hear from them again because they continued back on to whatever they were doing before they come talk to us. And over the course of the project, we have I think we have north of 900 code contributors to the in the code base, and that's not counting a significant number of people who have written blog posts and tutorials and provided a lot of the provided support on the mailing list and all the collateral and community you need around a project that isn't directly captured in the Git history. And something we probably should have led with is Matplotlib has been rewarded a $250,000 grant from Chan Zuckerberg to fund.
Wow! Awesome! Congratulations.
To fund the maintenance and development of Matplotlib for the next year. And one of the things that grant is funding is we're looking to hire a full-time software research engineer to help burning down our backlog of both issues and pull requests, and to work with and the other part of that is help funding Hannah for her dissertation, which she will talk about more later.
Excellent. So where do all these users and contributors come from? Like, what are the communities that they're a part of? I mean, you mentioned a few of them in the various different disciplines, but
we have all of them. We have. I'm just thinking, I've taught teenagers, undergrads, grads, faculty, postdocs. We've got Nobel Prize winners who use the library. So we had a tween contribute at a sprint.
Nice.
So
hey, awesome.
Yeah, we legit have users at every stage in their career. We have all the fields, right? We've said we have a lot from the science engineering, social sciences, digital humanities is a big new growth field. We have analysts who are working in industry, data scientists, visualization experts. And that's one of the most interesting things about our community. We've had contributions from communications majors, computational biologists, heliophysicists. So one of the interesting things about the library is because visualization is such a standard way to communicate is we have users who are coming in from the scientific stack or the data science stack, and so we have to deal with everything. Or let's put it this way. Our community includes everyone from a teenager who's trying to get a robot visualization working to a PhD in musicology trying to do their dissertation visualizations.
Right. Yeah, no, it's an incredibly open set of users there. So
yeah, it's amazing. Do you find that the users and the contributors are similar in their distribution across communities?
I think our contributors lean more from the STEM side than from other fields, and I think, but some of that is because I think open source culture in general has always lent itself more to, or been more like people in STEM are more aware of like open source libraries and contributing as a thing you can do.
Mm-hmm.
And I think like in the humanities, right, digital humanities and that whole conversation, it's there, but it's there in a different way. So I think like as it get like as we build more foundations in other fields, we're going to get more and more contributors from other fields too.
Awesome.
Right. So what tools are built on top of Matplotlib? What's out there?
So I think one of the really great things about Matplotlib is that we aren't necessarily the end of the plotting API, right? I mean, so like Matplotlib can be used directly by users for getting visualizations, but one of the very powerful things, if you have tools that are more aware of your domain, more aware of your data, they can do more things for you and make it much more fluid for the users. So
right.
There's things like Seaborn, which is heavily used in statistics and fields are very statistics heavy, and it understands what a data frame is and what statistics they want to see, and just makes them the visualizations directly. There's a library called Plot9, which is a re-implementation of ggplot2 style grammar of graphics API.
Mm-hmm.
All of Panda's default plotting is Matplotlib. So when you df.plot, that's a Matplotlib figure. All of Xarray's plotting. If you're in the geospatial space, there's CartoPy and Basemap, which do mapping. So actually, I think that globe Hana showed earlier, I think that's a Basemap one. And then I'm sure there are many, as you get out into the domains, there are people who have built themselves up small little libraries that solve the plotting problem, the handful of things they need to visualize regularly. And I think that is one of the biggest strengths of the library.
Right.
Yeah, it seems like there's tons of packages.
And YT, I'm sorry.
Oh, yeah. I gotta mention the one I work with. Hello. Yes, also YT. This is why I get to deal with Matplotlib a lot, and I really enjoy it. So, I mean, there's a very big diversity of projects that are built on Matplotlib, and so smooth transition here. Are there any? Is your project involved in any diversity and inclusion efforts for its users or contributors or something like that?
So we're trying. Like we did, and I look a lot of projects on the site. We do the Twitter call where like, hey, come join, we'll mentor, and we got like 50 DMs, and we realized that we need infrastructure for these people, right? Because one person, we love our people, we want all the contributors. No one person can a project does not have the bandwidth to mentor 50 people. And so we're like, let's ramp up, let's build out and formalize our sustainability things, our infrastructure, right? And Tom will talk about these in detail. But because we want to build a base so that when we come and mentor, we can point them to, here is the starting field, here are the resources, here are like how this project works, here's all of the hidden structure so you don't have to be here for 10 years to know what's flying. Because we feel that like you can't do diversity and inclusion if you don't have like a really good base for any new contributor to come in on.
And into the specific things we're working on, we do have a governance document, but it probably needs I'd like to look and overhaul that a little bit, make sure that's formalized and everyone accepts it's in force. Our code of conduct, currently we follow the PSF code of conduct, but we don't have any of the reporting structure around that, so we're working on that. As I mentioned earlier, the project has grown organically. We don't really have a roadmap. That is one of the things we want to do with the effort we have for the next year, is to write that roadmap so that when people come in and say, I want to contribute, instead of just looking through our issue tracker and saying like, oh, that one, it's very hard to tell if a bug is something that is a 10-minute fix or the bug the user reported actually requires refactoring half the library. So, a roadmap, to identify, like, if you want to work on big new features, if you're a company and you want to fund quarter FTE, what would that get? That sort of thing. And the other, the non-code parts of the community, we're also working on explicitly standing up and understanding and documenting. So we recently stood up a Discourse server. We're trying to move to that from our mailing lists. We found the mailing list usage has gone down, and hopefully, and a lot of the work that used to be on the mailing list has now gone to Stack Overflow. So we're hoping to capture some of that community back on the Discourse. We've recently started a blog, which is being maintained by actually someone who came from this Twitter call. It's matplotlib.org/blog, matplotblog.
Well, it's not a library, so.
So Hannah does an amazing job with our Twitter account, but we need to bring more, have more people help with that, because we need Hannah doing things that are not the Twitter account. We also have an Instagram account for highlighting cool plots. We need to formalize our administration and project management. As mentioned before, we have a team that, depending on how you want to count, is between 20 to 40 people, which these are it's all volunteer time, so it's a few hours a week from people here and there. But that still starts to be enough people that winging it is it works. We've been getting along, but it's starting to no longer work. We want to get ahead of that before there's a crisis and we have to solve the problem with things on fire. There's some work on the website, trying to overhaul the documentation of the website. Sorry.
Well, it seems like at this point we're diving into roadmap territory rather than diversity and inclusion territory. So I would recommend that maybe we dive into, maybe we shift gears a bit, go into our demo section. We'll get back to some of these roadmap items at the end of the episode here. So
I do want to just bring this back to diversity and inclusion.
Sure.
Which is that what we're trying to say by listing all these things is that we have all of these ways for people to get involved.
Yeah.
Which isn't just code. Like Matplot Art was set up by a communications major. The website is by someone who has experience doing website design. So
right.
You don't have to be a hard STEM person
to get involved. Right. No, that's a very good point. And I think we can actually dive into some of these particular issues in a few short minutes here, but why don't we go ahead and move into the fun demo section, which I know that we're all excited to do. So I believe you have a link for folks that we can get sent out, and just a reminder to anyone who's watching live here, if they want to ask any questions, please do while we get the webinar, or while we get the demo example up and running. And yeah, we'll be sure to answer your questions at the end as well. So.
Yeah, it looks like the link to the demo is now posted in the chat as well, for those of you that are interested in following along.
Yeah. Did Hannah or Tom, did you want to share your screen here?
When I restarted my computer, I needed to pop up Jupyter Lab. I don't remember that now. So give me half a second, or however long it takes Jupyter Lab to
the return of the technical difficulties. So.
I'll reach you with the binder link.
Well, it was really exciting to hear about all the different ways that people can get involved in the project. You clearly have thought about a lot of different pathways, and it's nice that people from all different backgrounds can get involved at whatever experience level that they have.
Yeah, I think that's really important, and providing those on-ramps is also very important, right? Especially in identifying kind of those personas of people who might contribute and how they might contribute is critical. So,
yeah, and it can be really challenging as an experienced developer on a project to come up with those, I think. So it's really, really cool that you have them.
Yeah. Especially since it's something where, sorry.
Okay, so I'm trying to.
I can also try to bring up this link if we need.
Which notebook is it, Hannah?
Do you see the do you guys see the Jupyter notebook yet?
No, you need to share your
Okay.
screen. So,
Okay. Sorry.
yeah, so either under actions or underneath.
Yeah.
There we go.
Hey!
That was because I have my poor laptop, so it all looks the same. Okay, you see a Jupyter notebook?
Yep, we do. Yep.
Okay, so what we have, the demo is going to walk through one task, which is teaching ordinary least squares regression on the MNIST data set, which is digits. So we want to recognize digits because, right, Matplotlib is a research tool, so we want to show you how it can be useful in your research, in your work, in kind of explaining data. So we import all the things, and here we're going to be using the IPyNPL Jupyter widget backend.
Cool.
These first things are not Matplotlib. They're just like, we're going to load in our data.
Right, just some imports, get everyone happy.
Load in the files, which are sitting in that binder repo, so that should work too. We're going to train and test our data, because training and testing is good.
I believe you completely. Yeah.
I trust you, Hannah.
So it's a linear regression. Linear regressions are y equals mx plus b. So what it is right, we're going to multiply the coefficient by our observation, and that's going to get our data. So we want to visualize, like, what does this mean?
Mm-hmm.
So we're going to make a heat map, and we're going to make a heat map of our coefficient, and we're going to make a heat map of our actual observation. So the coefficient, the observation.
Mm-hmm.
And the idea is your class is you multiply the coefficient at a pixel by the pixel. So that's how this decides is if it's a 0 or it's a circle. So heat maps here, right? We have a lovely diverging color map. We have a continuous color map. Next, though, is this is one observation, but we have the whole family of observations. So we want to see the linear class, like, what is this coefficient times classifier distribution look like for all our data, right? Is our data cleanly, like, is there a clean class split? So next we're going to make the histograms of our classes. And this is a little confusion histogram, right? We're going to show this, the orange is one class, the blue is another class. The yellow is what the prediction is going to say it's in, and the Y is what the prediction is going to be, predicted output. And so you see that we have a lot of data that's coded wrong.
Can you scroll up just a bit so that we can look at the code for this plot? Yeah, just to see, like, this is what I think is very incredible about Matplotlib, right? Is that this plot was all generated with not that much actual code, right? Once you have the data and everything.
Yeah, like the imp show is also the visualization for the imp show is this one line.
Right.
And now I have my pretty picture, and then I can set all the things, and
right.
Yep, it's one line of code there, and then, by the way, and this is all you need to make a color bar. You pass in the image, and then we automatically pick up what the lines and coloring is, and we'll throw up a color bar there for you.
Right.
Yeah, that's really nice.
Yeah. And here, there are multiple ways to do this. I decided the easiest way to put in a background was to just say, hey, everything from 0 to 3, color in this color. And then it'll just set it. Everything from -3 to 0, color, and it'll just do the thing. You don't have to fuss around with figuring out how to set backgrounds.
Right.
And you make the color bar, our labeler picks it up, we can put our label, and we can customize the labeling. The legends, like the end call feature is great if you just need that slight more polish.
Right.
And so,
go ahead.
right, and so we have this mismatch here of blue is yellow-blue means that we're misclassifying this data, and we're not really misclassifying any of the other class. So we can change that using what's called an alpha parameter, and the alpha parameter will let us kind of shift our classification. So we can first of all, let's see what our alpha parameters look like. And this is not Matplotlib yet. And yeah, we're going to make a little line plot, and all you need to make a line plot is you put in the X, you put in the Y, you put in, that is not actually the line. Here's the line plot. X, Y, color. You have a line plot. You can dot it, and then you can annotate the text. So we have a labeled line plot. And this is great, but what we really want to see is how these interact, right? How moving our alpha moves our classification, and the other way around.
Right.
And so we're going to make an animation. And to make the animation, this is all the same code we've just used. It's just put together. But we've already done this code.
Okay.
So that's what's about base image. And then for our animation, and this is more complicated than you need. This is just Tom going overboard. So
You're so efficient.
All you need for your animation is we're going to draw the histogram again with the little change, and we're going to set the new location on the scatter. And we're going to set the new label. And we put that all in animate function, and then we tell Matplotlib, hey, animate this. Using our different alpha values, because frames will take in the alpha, make me an animation. And I think I forgot to set this. I have the little capture keyword up here. Capture so that I don't have to, so that it doesn't show this base image. And we're going to use the animation to GHTML to visualize this because it's great. And now I can click buttons and I have an animation. I can have it play. I can also have it step through one of these. Oh, this is the step through. And I can step through slowly.
Right.
And that's cool, right? But what if I want to like get in there and actually touch it? Well, I can use Jupyter widgets from IPyWidgets, import interact, and then all I have to do is throw a decorator on my animate function. That's it. Put on the decorator, say alpha is equal to that values, and now I have a slider.
Whoa.
Whoa, this is awesome.
Shift the alpha, I can shift the alpha. And this is fun, but now what if like, but I want to actually touch it and drag it. Well, we can do that too. So you've seen all this code before. I just switched it to a different page because that notebook was getting too long for my taste.
Yeah.
So
and this is all
Matplotlib has
just running in the same kernel, right? So you don't
Yeah.
need like a little Flask server or something.
Nope. And Matplotlib has really advanced event handling now. All you need to do to get stuff animated is on a good chunk of our functions is set this argument, picker equals true. If you set picker equals true, now Matplotlib is aware of that plot and knows, hey, I can look at it. I can look at it for event objects, for events. So I'm going to show the visualization first, and then we'll go back and talk a little.
Okay,
So,
we have about 1 minute left in our demo time here. So.
Okay, but I have to show this. Now, see, drag it, and that's how the alpha changes.
Nice.
And it's bi-directional. I can drag it.
Oh,
And then this
very
updates
cool.
it. Yeah, and you can smooth this out. To make this, we have 2 events. When I press the button, I'm going to register it, and I'm going to register which type. And then when I release my press, I am going to get my X and Y, and then I'm going to look up my choices, and then I'm going to update my plot.
Very cool.
Very,
Now,
very
does this same code run in any of the interactive front end or interactive backends like Qt or any of that? Yeah, so it's the same for HTML as it is for any of these other pieces.
Yeah, this
That's
one
really
will.
cool.
Yeah, this one, the interactive will. The only one that won't is this because it relies on the Jupyter interact slider, but you can also use
Right.
the native Matplotlib slider, and then it'll work in whatever backend you want.
And if you, and just as you could use the native IPy widget slider here, if you were working in a, that is deeply upsetting.
For the listeners at home, it was just a recursive screen share, and Tom was scared. Okay, Tom.
You can use the native GUI widget toolkit to provide the sliders as well.
Right.
Okay.
Very cool. Yeah, it seems like there's a whole abstraction layer for all sorts of interactivity now in Matplotlib to enable all this stuff.
I mean, that has been there almost from the beginning. If you use the pan or zoom functionality on a Matplotlib figure, that is the machinery that's doing that, and all of those hooks are available to you as a user.
Yep. I've been using that GTK pan and zoom tool since at least 2006. So I know that it's been there for a while, but I hadn't seen it in some of these other backends. It's really
I also want to stress though that it's really easy because it's I'm gonna actually just share for 1 second to show one thing. Sorry about that.
The return of the demo.
Yeah.
It appears.
It's totally fine on it.
Here, this is the one line of code that now that one line of code, and now your figure is event aware, and you can do the interaction.
Mm-hmm. Cool.
That's probably my favorite part.
Yeah, no, that's amazing.
Oh, there's an infinite screen that Tom's afraid of.
Nice. All right. Well, let's now move on or move back to not the demo, but the roadmap discussion. So, Tom, Hannah, take it away. So I think, I in addition to emphasizing sort of the diversity of people and contributors to Matplotlib, these are places where folks can contribute not only code, but if you happen to have deeper pockets, these are areas in which Matplotlib would benefit from funding or benefit from, human resources being donated to these particular tasks. And there are places where the project is already going, so they're already aligned. So if these are things that you'd like to see done, you can help bring them into existence just that much faster and much better. So Tom and Hannah, take it away. What's on the roadmap to start with?
So I guess the link that just got put in the chat is a link to the repository, to the grant we wrote to Chan Zuckerberg, which is what we're committing to do for the next year of effort. And there's kind of two big branches of that correspond to very roughly where we think the library needs to go. On one hand, we just have the straight maintenance, keeping the lights on, doing, helping users that are having issues. And that's something where that's just like, we have to not break what we have, right? It's not particularly glamorous, which is actually why this grant program from Chan Zuckerberg is so amazing, is that they explicitly targeted paying for this maintenance effort rather than for the next new shiny feature, such and such, all of that. And the other half of it is, as I mentioned before, there's a lot of libraries built on top of Matplotlib. But the path to writing those for the library authors is not as smooth as it could be, because the API for Matplotlib actually is very focused on to the user who's writing it for their own use. That's there's parts of Matplotlib which are very much an application, and trying to write a library on top of an application can be challenging. And so we want to look at how to re-architect Matplotlib to make it much easier to write a very thin domain-specific library on top of Matplotlib, to make it possible for Matplotlib to natively support the advances in like data structures that have happened in the last 2 decades. Right now, we don't natively support pandas data frames or X-arrays. You have to take those beautiful objects, which have all sorts of strong information in them about like how things relate, and rip them apart into individual arrays and hand us the single arrays. It'd be much better for the end users if they could have a library that understood both Matplotlib and that data structure and could just use it directly.
Right.
And stress for the maintenance side, we are hiring. There's a please apply.
What would your ideal candidate look like? Do you want to talk a little bit about that?
So that's a good question. So we're looking for someone who they need you need to know Python. You need to be comfortable working in the library. You need to be comfortable working in the open, because they're going to be working with the community to triage all of our issues. So you have to understand what the bug report is, and then
you have to understand the community to talk to them and get them on board.
So we need someone who is comfortable doing both the programming side and digging into Matplotlib and fixing bugs as needed, and also someone who can work with the community, help foster the community, and interface with our users and the downstream libraries that we want to engage with.
Right.
So
now if we can go back to the re-architecture question, the re-architecture item rather, my question here for you is, Matplotlib has always had a sort of lower level object-oriented API that I think very few users use, unless they've really gone off the rails. It's not everything that they need is in PyPlot necessarily, but is what you're saying is that lower level API itself is not good enough for some of these projects, or are you talking more about like re-architecting how that is built, or where's the re-architecture going to happen, I guess?
So it is at that lower level, and it's not so much that it's not good enough, it's just that the way it's structured right now, what happens is the data is really deeply intertwined with how things are drawn, which is the plots, what we call the artists.
Yeah.
Basically, and what happens is because of that intertwining, like that's a lot of why right now to pass label data into Matplotlib, you have to do all of this, 14 steps, or it gets like making a dashboard or doing streaming data updates or stuff can get really complicated, because you have to go into the actual artist and pull out your pieces,
right,
and pull out your data, and pull out the data in whichever form Matplotlib has it down there, which sometimes isn't a form you'll recognize, to update it. And so one of the major things we want to do is on that layer is start like really disentangling the data from the artist, because if we can have a data as like its own thing, then we can start doing, like Tom was saying, the complex data, or give the users and the developers the chance to subclass our data objects for their own data. And then it becomes a lot cleaner to natively support something like a task array, an X-array. But also, some of the motivation for this project was like, I was working with categoricals, and we really want string data to be a first-class object,
right,
first-class data. And to do that right now is tangled, because you have to run through our conversion system that gets hit every time you want to make a plot with this data. And being able to, again, disentangle the data from the plot lets you now have this as like a first class object, because you can start doing like this conversion once on the data instead of trying to remember has it been done in every plot. And this also works for like date times,
right.
Which
So
I think is the most common use case.
So some sort of data abstraction layer. Would you be working with like NumPy's like array function idea, or arrow data frames? Like, what's kind of the underlying model that you're thinking of having here? Like, what
part of it is we're trying to keep this as abstract as possible, because what we really want is we want people to be able to like hook in their database as much as hook in Arrow or Parquet or whatever.
Right.
But on the flip side, like down at the bottom, everything usually ends up a thin wrapper on NumPy, but I think we all think of stuff like the U of A broadcasting. So if we can like pitch computations, like let Dask natively do its computations, right? That's better because it'll be more efficient. So I think that those are some of the trade-offs we're looking at as we think through the details of this re-architecture.
Right. Yeah, that's really exciting.
Yeah.
Are there other elements of the roadmap that you want to bring up or chat about?
Yeah, two things. Like, also, Tom, you want to say something?
No, you can go.
Okay. As part of this re-architecture, we're also thinking about like actually doing this reference spec with a very like functional Haskell oriented framework. And the idea behind that is that if we have this, like, it's kind of like a theoretic formalization, because if we can get that theoretic formalization right, then we kind of can start thinking about robustness of the visualization, and we can like fold in stuff like type constraints, which is stuff like you as a third-party developer can start being like, you can start thinking about making your visualizations type consistent. You know, you can start requiring users to do that, but like we'll have the hooks in place to support that. And if we take a functional approach, then we can start thinking about things like, concurrency and speed ups on large data sets, or reliability streaming. So we're thinking about like also adding in this formalism at the front.
Yeah, that's really interesting. How would that relate to efforts like Vega and Vega Lite and Altair? Things there where there's a formal specification for the plot.
So for us, this is less formal specification for the plot, more formal specification for the architecture that draws the plot, which is a different side of it.
Right.
Where we're thinking of the formal specification plot is we're thinking is all sorts of serializability. Like if we can start because I know everyone wants a .fig, so it's like if we can start thinking through, and again, this is also what's separating out the data from the plot lets us do, is start really thinking about like what would a .fig look like.
Yeah, that's fascinating. I didn't even know I wanted a .fig until right this moment, but I want it now. That's great. Okay, well, I think we're kind of unfortunately out of time for the roadmap discussion, but I do want to just reemphasize again that these are all great places for people to jump in and contribute either code or ideas, or again, if you have money, funding to participate in Matplotlib, and the CZI grant, is more to do maintenance stuff, and this is kind of a little bit more looking into the future of these roadmap items, and it's all very, very exciting. So with that, we have a few questions from our viewers here, so why don't we go ahead and get to those? Right.
Yeah, okay, so our first one has to do with the binder example. So Perry Grossman asks, thanks for the info. I may have missed something. He's a little late to the example, but running the binder file for the alpha demo binder file, for cell 11, they get type error, expected max size to be an integer or none. Any suggestions on that?
This is a bug report.
You got a live bug report.
Yeah. What's
I think, can I debug this while we ask other questions?
We don't even need, we can debug this outside of the webinar. This is the first bug report I think we've received live. So
congratulations, Perry, on the first bug report of this webinar.
We're not going to be solving it right here, right now. And Hamir asks, is there a plan / functionality for 3D plotting?
I mean, we have 3D plotting.
So right, we do have 3D support. You can, if you're feeling uncharitable, you can call it 2.5D support. So if you give us 3D data, we have all the code to project that, given a view angle, to project those points into the 2D space and then render them in the correct place. What we don't have is a proper Z buffer. So if you have two intersecting artists, we draw one and then we draw the other, so you get very Escher-like effects if you're trying to do intersections. And we're doing this all basically in software. We're not making any contact with GPUs. I think if the re-architecture Hannah was talking about earlier, if when that is done, I think we'll be in a much better position to look at how we could start pushing some of our rendering to a GPU. But the way it's architected right now, we do so much of the transformations in Python that by the time we hit the GPU, we've done all the work and you don't get any benefits. So,
right. So yeah, I think the point you're trying to make here is like, it doesn't necessarily make sense to be going and putting this in VR or anything. Like, it doesn't really do that sort of work. Like, that's all done in different engines. So
I will say I did have a
Okay.
student generate a VR Matplotlib image if you want to do like a panoramic view thing.
right. Yeah.
Oh,
That
cool.
would be-
Okay, so Peru actually asked a very cool question, which is, what would be the coolest feature that Matplotlib is currently missing? So I guess this is your wish list of like the thing you want.
I mean, it depends on the user, right? The coolest feature we're missing is the feature you most want.
Python truly does have reflection.
So
for Anthony, it's .fig, it sounds like.
I think the thing that would a cool thing that would benefit a lot of people immediately would be a better story of how to lay out multi-axis plots and how to efficiently work with complex layouts on the figure, right? If you want to put one axis on the figure, we're great. If you want to do, one with two parasite axes, that's also pretty doable right now. If you want to do a grid of axes which have parasite axes, some on the left, some on the right, some on the top, some on the bottom, that starts to become very gnarly to lay out. And I think tooling around that is a very cool feature that it's a fair amount of work to get right, but I think that'd be a very cool feature to have. And we've started to lay some of the groundwork for that. We recently, maybe 3.1 or 3.0, we picked up the ability, we have a linear constraint solver layout. So if you do constrained layout on your figure, it will make everything fit using the Cassavary algorithm as efficiently as possible.
Very cool. Well, that's all the time that we have for questions. It is now time for our world famous rant and rave section, where we each get 15 seconds to rant or rave about a topic of our choice. Tom, it is your soapbox.
So I think when building software, either you're building an application where the correct thing to do is to guess what the user wanted and suppress all errors at all times and just do the right thing, or you're building a library where the right thing to do is to be very strict about your input, fail early and often, and provide tracebacks, exceptions saying what went wrong. I think a lot of pathologies that show up in open source software is when one code base is trying to do both, and in some places it does one, and in some places it does another, and it's just very frustrating.
Hannah?
I don't like how visualization, so sometimes, which is that a lot people will throw up like a terrible visualization, absolutely trash, and ask students like, what is bad about this? I think instead you need to do it like art, where it's like, here are the fundamentals, here are the rules of how we go from data to visuals. Now let's look at this image and be like, what are the choices? What is the intentionality that the creator did in making this visualization and choosing to make the point be this date, like the this variable, and the color be this other variable. I think that works better in teaching people how to make good visualizations than just tearing apart bad ones.
Yeah, that's the epistemology there is right on target. Madigan, it's your soapbox.
Well, mine isn't quite as good as either of the previous ones, but I think everybody needs to admit how much they like Europop. People like to hate on it, but it's a pretty great genre of music. I know you all secretly love it, so.
Hear, hear. For my rave today, I'm just going to quote a tweet from Jim Christ Harif today. So he tweeted out, "Went to see Death of a Salesman at a local theater last night. It started behind schedule. The lead actor got stuck at their other job. It was late stage capitalism." Thank you, Jim. Many hearts for that. That is all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including Matplotlib, you can find all of the project roadmaps at quansight.com/projects. Tom and Hannah, where can people find you and Matplotlib?
The discourse at matplotlib.org, the Twitter at matplotlib, at matplotblog, matplotart, which is the Insta, and the Gitter.
Perfect. Thank you. And join us again next episode for a fun discussion on Stumpy. Bye, everybody.